Welcome to F5 Distributed Cloud demo on Telco Cloud with Service Proxy for Kubernetes or SPK. In this demo, I'm going to show you how you can run a 5G service-based architecture with F5 Distributed Cloud AppStack. I'm going to use SPK to provide high resiliency and load balance AMF network function. I'm leveraging Orange open source provided Helm chart, which is based on OpenSource Free5GC, which is an open source project for 5th generation's mobile core network. Here, what I'm going to do. From F5 Distributed Cloud Console, I have onboarded 3 nodes AppStack Telco Cloud cluster. AppStack can be managed from F5 Console. Then, I will deploy various Free5GC network functions. This will onboard various 5G network functions. In this demo, I'm going to deploy a replica set of 3 AMF functions. This Telco Cloud cluster will form the 5G mobile core control plane. I already pre-deployed a UPF on an open source Kubernetes. This UPF runs on a dedicated standalone Kubernetes with a simulated 5G user end and radio access network, or RAN. I'm leveraging on an open source UE RAN simulator. I will also deploy SPK on the Telco Cloud to load balance those AMF functions. RAN and UE can establish SCTP and NGAP connections to the SPK via N1 and N2 interface. To unpack how the SPK works, here is how it looks like. F5 TMM and F5 controller, or also known as F5 ingress, form the core component of this AMF load balancing. F5 TMM external interface is exposed via Maltus CNI, where UE connections via this N1 or N2 interface. In this demo, I'm using MAC VLAN CNI to expose F5 TMM external interface. F5 internal interface IT0 is connected to AppStack Argo data plane. This is the Kubernetes port network. SCTP and NGAP will hit F5 TMM, and F5 TMM will load balance to AMF via Argo internal port networks. F5 controller constantly monitor AMF services for port lifecycle and dynamically program F5 TMM data plane. Here is the detailed view of the setup with all the respective IP addresses. In this demo, I'm only leveraging a single F5 TMM. Multiple F5 TMM can be deployed. A BGP sessions can be established with external router to drive traffics to multiple F5 TMM ports. Let's jump into the demo. Here is my F5 Distributed Cloud console. As shown here, I have this F5 Telco Cloud's AppStack deployed and currently managed within the F5 console. This is a 3-node cluster. Now, I have multiple sessions here open. I have this, I label as F5 TMM. Later on, what I'm going to do is that I'm going to show you the logs. And then I have AMF1, AMF2, and AMF3. So because I have multiple AMF here, so I pre-log into 3 sessions so that I can see the logs. And I have a SMF as well as just a blank screen here. I also have this, this is where the open source Kubernetes, this is around the UPF. So if I press L to see the, now currently is waiting for logs. So what I'm going to do is I'm going to constantly monitor the namespace. A namespace been created. Currently, nothing's got deployed yet. So what I'm going to do is that the first thing that I'm going to do is that I'm going to deploy the Free5GC. I have a predefined scripts to say install this one. You can see that all the screens are showing the same thing because I have pre-monitored all the namespaces within the towards F5GC. Give it a couple of minutes before all the ports are spin up. So what I'm going to do is that within this, this is for the F5 TMM. Currently, I haven't spin up any F5 TMM yet, so I'm going to wait for this for a moment. So now you can see that I have 3 AMF 1, 2, 3 replica set. So I'm going to monitor the logs for this first AMF. This is the second AMF, and this is the third AMF. And in this one, I will monitor the SMF. I will monitor the logs. Alright, so now the second thing that I'm going to do is that I'm going to deploy F5 SPK. Okay, ingress. So 10 install. So deployment of F5 TMM or F5 SPK, the same thing as well. In my case, I have this F5 ingress, or this is what we also call F5 controller. This is the one that is constantly monitor the AMF services to make sure that to monitor the port lifecycle. Now currently F5 TMMs are up and running. Let me press L to constantly monitor the logs. So what I'm going to do is that once I set it up, I will install the SPK VLAN, the VLAN CRD. So the SPK VLAN CRD have this 10, 16, 200 as the self IP addresses, which this is exposed to the external network. Alright, so now you can see that I have created the this SPK VLAN. Then the next thing here is that what I'm going to do is that I'm going to deploy the NGAP CRD to load balance the AMF. So the same thing as well, I have deployed this, but before I deploy the NGAP CNF, I need to modify the NGAP CNF. So basically this is what the NGAP CNF looks like. 16200 is the ingress IP address, 38412 is the SCTP port. And what happens is that in this version, I have to specify the SNAT IP address. This SNAT IP address is the internal IP addresses of the F5 TMM. In this case, will be 100.3.253. Alright, so now what I am going to do is that the same thing, I'm going to constantly monitor this one. I am going to run the install the Free5GC. So from here, you can see that if I scroll down slightly a little bit here, pause this one, you can see that the pool member, this one is the SNAT pool. This is where the F5 TMM source net, when they talk to the AMF, you can see that it discovered 3 AMF, which is 3239, 3243, and 3244. Basically, that is this IP address, the AMF IP address, 3243, 3244, and 3239. 239. Yep. So if I go back to here and keep monitoring the logs. Okay, now what I'm going to do is that because I already set up the towards Free5GC, everything is up and running. I already have the SPK, and the F5 ingress already constantly monitor the AMF, as well as now what I'm going to do is that I'm going to create a user. So what happened here is that I pre-created a load balancer, which is for the Free5GC, the web UI. I have to provision a user. I'm going to log into the Free5GC, log in. So I'm going to create a subscriber. So currently there's no subscriber created, a new subscriber. I'm going to leave all as a default and put submit. So now a subscriber are created. Under the real-time status, there's no user at all here. So what I'm going to do is that I'm going to go back here. Let me make sure that we constantly monitor the logs. Okay, so now I pretty much have, by the way, you can see that there's a session establishment here, the new nodes. Actually, this is from the SMF. because you can see that sending a PFCP association request to the UPF, which is 17168, which is this one, and this one received a new note on 17101, which is the SMF. So because SMF listened on 17101, and then it sent PFCP request, and then receive PFCP association accepted response from this SMF, which is 17168. So you can see that the SMF and the UPF are communicating via the N4 interface, which is this N4 interface. All right. So so far so good. So now what I am going to do is that I already created a user, a subscriber. So now what I'm going to do is that from the RAN, I'm going to run a RAN simulator. I have this 01. You can see that if I pause it here, pause the logs, if I scroll up to show you what's happening at the background, you can see that there's some communication happening. Client accepted from my UE to this 200, 38412. Then you can see that the server connected as well here. So what I mean here is that the SCTP establishments between this RAN with this F5 TMM, and you can see from here, it actually hitting the let me scroll here a little bit. It's actually hitting the AMF number 3. You can see that create a new NG connection from this one. Now what I'm going to do next is that I'm going to run the UE client 02. All right, so now you can see that 02, the same thing. I'm not going to show you the logs here. The logs on the F5 TMM, there's a lot of communication happening between the UE N1, N2 with the F5 TMM. You can see that a tunnel interface established, 10101 is up. So if I IPA, you can see that the UE simulated tunnel 0 is called set up. This tunnel is actually the tunnel between, if I go back to the diagram, the tunnel is actually between the UE and the UPF. This is the entry interface. So you can see the logs here shown sending PDU sessions for request and handle PDU sessions ran and so on. So if I may make this slightly smaller so that you can see the full logs here. So what it's showing me is actually hitting the AMF number 3. So if I stop scrolling, and you can see all the communications, the start initial context request, RAN, NGAP ID, and so on and so forth. You can see that it hit the F5 TMM, F5 TMM sent it to the AMF, and the UE client established a tunnel interface. If I go to the the Free5GC, if I do a refresh, you can see that there's an IMSI, which is this IMSI connected. This is show that the sessions established, and this is the AMF information, and this is the SMF information where a PDU address 10101 is given. So if I scroll back here, the 10101 is given to the UE client. So from here, you can see that the sessions from the UE, the RAN, and the UE successfully established to the UPF. And of course, in my case, it can get to the internet via the N6 or the CGNet data network. The other things that I would like to demonstrate as well is regarding the visibility from here. So if I go to the distributed apps, and I have to go to the service mesh and do a refresh and see whether, yeah, you can see that if I go to this towards Free5GC dashboard, this is the analytics that you can observe from the telco cloud. Like for example, currently, let's say for example, if there's a lot of connections happening, then you can see the communication between them. Let me last 1 hour to see whether do I have anything here. No. Okay, let me generate more traffics. If I do a Ctrl C, if I run it again, establish a new sessions, Ctrl+C. Now it's actually .3. So you can see that potentially the second round it may hit. I think the second round is probably hit the AMF number 2. That's why on the AMF number 2, you can see the sessions is running there. Let me run again. Now this time you can see that it's hitting AMF number 1, I believe. Let me see. Yeah, it's hitting AMF number 1. So you can see that it's actually load balance between all the 3. Okay, so I potentially already generated enough data here. Let me this is 10. Okay, now if I go back to the session is actually .10. If I do a refresh here, refresh, show info. Now you can see this is 10.1.0.10. This is the latest sessions. If I refresh it, see whether, yeah, you can see that there's a more connections happening. It gives you more visibility and the states of all the connectivity, the health as well. So if I want to see the logs, I should be able to see the logs here. So this is the service mesh or the visibility that you can get from this telco cloud. Yep, here basically this is all the demo. Hope you enjoy it, and feel free to reach out if you have any questions on to have a one-on-one demo to see how it works. And thank you for watching, and have a great day. Thank you.